Good morning. This is Ms. Billerbeck, and we're going to talk about 2.6 real numbers. So real numbers are all the rational numbers and irrational numbers. So if we look at this, we have real numbers. So here we have our natural or counting numbers, which are 1, 2, 3, 4, 5, 6, then whole numbers, which include 0. Then integers that start including our negative counting numbers like -1, -2, -3. Then rational numbers, which can be fractions, positive or negative fractions. We have positive, negative. They could be terminating decimals, and repeating decimals are all rational numbers. We have another category called irrational numbers, and those would be things like pi and pi, and then you have the square root of 2. So let me write that pi a little bit better. So pi, can't quite see it. So that's a pi. All right, so these are also decimals that never end. So pi, of course, never ends. So that's why it's irrational. The square root of 2 never ends. Well, these are inside real numbers. So real numbers include rational and irrational number sets. So this is called the number family. So let's look at this. Let's see what kind of decimal we're going to get here. So if we always remember, the top number goes into the house. So top number in the house, and the bottom number is on the outside. So if we look at how many 8s are in 5, 0. How many 8s are in 50? Well, that would be 6. So we have 48. We subtract, and we have a 2. We drop down the 0. How many 8s in 20? Well, there's going to be 2. So 2 times 8 is 16. We subtract, we get 4, and we drop another 0 down. And how many 8s in 40? And there are 5. And when we subtract, we have a 0. So this is called a terminating decimal, because it terminates. It ends at 5. We have a 0 remainder, so it's terminating. Let's look at this one. So we have 0 11s and 7. There are 6 11s and 70. We subtract, we drop 0 down. There are 3 11s and 40. And we get a 7, drop that down. And we have 70 again. So we look at, well, there's 6 in that. So we have 66. Getting a little messy here. We subtract, and we drop another 0 down, and 40. And we see, it's just going to keep repeating. So once we've repeated 70 and 70, we kind of knew it was going to repeat again. But now we have 33, 33 as well. So this is called a repeating decimal. So we can write this one as 0.63, and then it's just 6363. So we put a bar like that. And that's how we would write this repeating decimal. All right, so let's take a look at a few of these. All right, so what we're going to do is we are going to determine what part of the number family does this belong to. So we have pi over 2. Well, it has pi in it. So that means it's irrational. Because pi and its multiples are irrational. Well, this one equals 6. So that the smallest one would be a natural or counting number. This one, it's actually repeating. So we could write this as 2.251 with a bar over it. So this is a rational number because it's repeating. We just had to go a little ways to see the repeat. This one, it has a negative in the square root. Well, that's not even real, so it's not real. So this one's not real because it's an imaginary number. It doesn't fit in our number family that we just went over. And then this one equals negative 15. So we have an integer. Okay, so negative 15 is an integer. Okay, the reason why you can't have a negative in the square root. So nothing squared is a negative. So that's what makes this an imaginary number. All right, you'll learn much more about that in Algebra 2. So let's look at this one here. So this says, represent the following number on the real line. Ooh, well, that's a little troubling. So it's between this and it's between, let's see, this. But it's much closer to 16. So if I were to write this and show 4 here, because this is 4 and this one is 5, write the 4 over here. So if I were to write 4 and 5, I'd probably put square root of 17 right there because it's very close to square root of 16. So this one says represent the following number on the real line, square root of 13. We've got another irrational, yes, it's an irrational number. So this is irrational, like the last one was, because it doesn't have a nice integer value. So this one is going to be between 9 and between 16. So this is 3 and this is 4. Okay, that one is very much in between. So what I would say is if we had 3 and 4, I would put square root of 13 is 3 away from this, and it's 4 away from that, so it's just a tiny bit closer to 4. So I put square root of 13 right there. Okay, so this one says name the set of numbers negative 18 is a member of. Well, it first appears as an integer. And then it's a rational number, because rational numbers encompass integers, and it's also real. What's the largest number set? The largest number set is real numbers. The largest real number set. There are imaginary numbers. Okay, name the smallest number set that 16 over 143 is a member of. Well, that's a rational number is the smallest one. Okay, so that just gives you an idea how to look at the number family. Okay. All right, so that's it for this section. So have a wonderful day.